Let us look at beta function. So let's take it step by step. We have already seen the gamma function. So gamma of p is equal to the integral from 0 to infinity of t to the power of p minus 1 times e to the power of minus t dt, where p is greater than 0. And let's take another gamma function. So gamma of q is equal to the integral 0 to infinity of s to the power of q minus 1 times e to the power of minus s ds, where q is greater than 0. Now we are going to multiply these two. So we get gamma of p times gamma of q is equal to the product of these two integrals. And in the previous session, we have seen Tonelli's theorem says the product of these two integrals is equal to integrating overall pairs x comma y. So here we have, instead of x comma y, we have t comma s. So which means we can write it as a double integral. Gamma of p times gamma of q is equal to the integral 0 to infinity of t to the power of p minus 1 times s to the power of q minus 1 times e to the power of minus t times e to the power of minus s dt ds. Now let's simplify this a little bit. What do we get? We have e to the power of minus t, e to the power of minus s, which can be written as e to the power of minus t plus s. Now let's do substitution. Let u is equal to t plus s and x is equal to t by t plus s. So what happens here now? T plus s is u. Take it to the other side, we get ux is equal to t. S is equal to u minus t, but t is ux. So s is equal to u minus ux, which is u times 1 minus x. If you remember the Tonelli's previous session, the region Ts is in 0 to infinity square, which maps to u comma x in 0 to infinity times 0 to 1. Now the area element transforms from dt ds to u du dx. Now gamma of p times gamma of q is equal to, now let's do the substitution, integral u equal to 0 to infinity, integral x equal to 0 to 1 of ux to the power of p minus 1, because here we have t is ux. So ux to the power of p minus 1, s is u times 1 minus x. So u times 1 minus x to the power of q minus 1 times e to the power of minus u times du dx. So here dt ds maps to u du dx. Let's take u to the power of p minus 1 plus u to the power of q minus 1 is there. So p minus 1 plus q minus 1 plus 1 times x to the power of p minus 1. This one, x to the power of p minus 1 times 1 minus x to the power of q minus 1 times e to the power of minus u du dx. So we need to be very careful with these substitutions. Simplifying it further, minus 1 plus 1 cancels out. We have u to the power of p plus q minus 1 times x to the power of p minus 1 times 1 minus x to the power of q minus 1 times e to the power of minus u du dx. Again, we split it. Remember Tonelli's theorem? We can combine them into a double integral, or we can split the double integral into a product of two integrals. So here we are splitting this integral, double integral. So integral u equal to 0 to infinity of u to the power of p plus q minus 1 times e to the power of minus u du times the integral x equal to 0 to 1 of x to the power of p minus 1 times 1 minus x to the power of q minus 1 dx. What is this? If we take it as p plus q as n, we have integral from 0 to infinity of u to the power of n minus 1 times e to the power of minus u du, which is nothing but gamma of p plus q times this integral. Integral 0 to 1 of x to the power of p minus 1 times 1 minus x to the power of q minus 1 dx. Now we can take this gamma of p plus q to the other side. So we end up with gamma of p times gamma of q by gamma of p plus q is equal to the integral from 0 to 1 of x to the power of p minus 1 times 1 minus x to the power of q minus 1 dx. This integral is called the beta integral and requires two variables, p and q, in the powers. The integral is represented as a function b of p comma q, where p and q are greater than 0 and x is in the interval 0 comma 1. While deriving this beta function or beta integral, we have seen that it is related to the gamma function. So we have beta of p comma q is equal to gamma of p times gamma of q divided by gamma of p plus q. That was beta function. Now, if you found this session helpful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.